Hello everyone. So today we will be solving some of the numericals and conceptual problems on the chapter we have studied, that is electricity. So we will be seeing some of the questions which are of more can be of a little advanced level, and some of them can be asked in your competitive exams also. So let us discuss them one by one. So the first question is that you are given four bulbs of 25 watt, 40 watts, and 50 watts and 60 watts, that is four bulbs of different power ratings. So what are these? So these are nothing but your power ratings. So these power ratings are given to you, right? So the power ratings are given as 25, 40 watts, 50 watts and 60 watts. Now he is asking which bulb has the lowest resistance. Now first of all, let me discuss about power. So the formula of power, you know, is that power is equals to V into I, and you also know that V is equals to IR. So if you use, suppose in place of V, you place IR, then you get P as I square R. And in place of I, if you are using this expression, so this I becomes now V by R. And this I, if you place in this expression, then P becomes V into V by R, that is V square by. Now you have these three different formulas, right? First formula is this one, the power is equal to voltage times the current. The second formula is power is I square R. And the third formula for power you can write is V square by. So these three are the formulas of the power which you are available to you, right? Now your task is, so while designing a bulb, right? So while a manufacturer is designing a bulb, right? When he is designing a bulb, what parameter should he should keep in his mind? First of all, I told you that the voltages which you are receiving or the potential difference is going to be constant. That is the V you are receiving at home, that will be constant and that will be same for everyone, right? Like here we have 220 volts. Let's say it is a constant voltage, right? So voltage is constant. Now, if voltage is constant, what is the design parameter available with this manufacturer so that he can decide the power rating? That is how up to what numerical value of power this bulb is capable of. So this material or the filament which is using to make this bulb, right? So this the resistance of this, right, will govern this power. Now you can see this expression, right? This expression you can use while tackling these kinds of questions, because the reason is that when a bulb is designed at that time, the voltage is to be universally same everywhere, right? And generally what happens in your electrical devices at home, all the devices are operating in parallel. And parallel, you know that in parallel when devices are operating, the voltage is always same, right? That voltage is always same and that the voltage is constant. So this is going to be a constant quantity. Now the manufacturer is left with this resistance. So what will he do? You can see with this relation that if voltage is kept constant, then power is inversely proportional to the resistance, right? So now this is the relation which will be used to determine the power. If resistance is going to be more, the power of that bulb will be less. Power rating of that bulb will be less, right? So whenever that bulb is connected, suppose that voltage is going to be constant, and now the bulb is going to be connected in a circuit. Let us say this is the circuit in which it is getting connected. So the current, what it will be taking, it will be taking the current accordingly. V is equals to IR, you know, that is I is equals to V by R. Now V is same everywhere. Now depending on this value of resistance, this current will be drawn by this bulb. So the meaning is that whatever the device which you are connecting across a fixed, a constant voltage source, right? So that time the value of resistance will be determining this current, right, dependent on the resistance of this, and then the current will be drawn and the power will be consumed accordingly. So on and all, what I want to tell you is that when a design is made or when a bulb, the power ratings are to be decided, then you use this formula, because voltage is kept constant and then value of resistance is in the hands of manufacturer. because the amount of current will be indirectly controlled, because directly by tweaking this bulb you can't comment on the current, right? So if the resistance is altered in such a way, then they can control the amount of current. So power, then the current will be controlled and I square R will be the power, right? So on the design parameter, only this resistance is the value which the manufacturer can alter and decide the power ratings. So as I told you that now by this formula, so let us clear the clutter, right? Let us leave only the formulas now which are needed, right? So this is the formula now we have finally, right? So this is the formula which you will be using, and it tells you that resistance increases, power rating decreases. That means the power rating will go down as the resistance will be increased. So that means the maximum power resistance, right? The maximum power rating bulb will have the minimum resistance. Right. So by this formula, you can understand that why we are considering this formula, with this in consideration. I can't, I am not using P is equal to I square R to comment on this power rating, right? Because the reason is that this I square, this I current will depend on the value of this resistance, which will be decided at the time of manufacturing. Right, so that the appropriate material or resistance will be adjusted at the time of design of this bulb only, right? So accordingly the power ratings are decided. That is, if resistance is going to be increased, right, if resistance of a particular bulb is more, the power rating will be lesser in that bulb, right? So that is why the 60 watt, here what will happen, the 60 watt, the resistance value of this, let me use some, what will happen here, the resistance of this 60 ohm will be the lowest, and the 50 ohm will be the more than this, and then the 40 ohm will be the more, and the maximum resistance will be of the of the least power rating, right, which is your 25. So this 25 watt will have the maximum resistance, and then 60 watt will have the minimum resistance. So 60 watt will be the answer, because v is in the, because power is inversely proportional to the voltage. Power is equal to V square by R, and if this is will be constant everywhere, right? The supply systems we are mentioning the potential difference, it will be same, it will be constant. Then in that case, power is inversely proportional to the resistance. And now what will happen if resistance is low? The current drawn will be higher, right? And then I square R will be higher and the power will be higher. So that is, by designing this, choosing this R appropriately, this I will be controlled, you can say, indirectly. That is why we are using this formula, right? Let us move to the next question. So a person connects four cells in series with terminal of one cell reversed. Okay, each having an EMF of 1.45 volts. So let me tell you something about this EMF. So this EMF stands for electromotive force. So electromotive force is what? Whatever this, suppose this battery is there and we are measuring this terminal potential difference across this battery, then whatever volts we are getting, it is nothing but your electromotive force only, because that is the potential difference is creating an is responsible for the movement of electrons, that is responsible for the movement of charges. Sometimes what is, suppose I'm saying 12-volt battery, so this EMF is nothing but what is 12 volt only, right? This is equal to 12 volt, this is the mean. Clear? Now a person connects four cells in series with terminal of one cell reversed. So let us draw the diagram, right? So he's seeing four cells. This is the cell number one, this is the cell number two, this is the cell number three, and he is saying that this is connected in series. And what he is telling, that terminal of one cell is reversed. So that means that one cell is like this only. So this is the case, right? So this means this one is supplying 1.5 volt, this one is also 1.5, this one is also 1.5. And what will happen, since this is plus, this is minus, but what will happen, Okay, let me do the reverse terminal, right? So this is connected in the reverse direction. So let me do it. So these terminals are reversed of one, right? This is plus, this is minus, this is plus. So this will be what? Now, since the one terminal of one is reversed, this will be minus 1.5 volts, right? So what is now happening? The internal resistance of each of the cell is 1 by 4 ohm. Now practically what happens? We represent a cell like this, right? Or a battery like this. Now in ideal conditions, we are not considering any resistance of a battery, right? But in real condition or in practical life, what happens is that this battery or cell is also, this cell is also having a small resistance, and that small resistance we call it as internal resistance of the battery or the internal resistance of the cell, right? So this is what we call as the internal resistance. And obviously these cells are connected in series, then this internal resistance of each cell will be connected in series also, right? So the internal resistance of each is 1 by 4 ohm. So let me draw it more appropriately to you, right? So suppose this is the first cell, and this is the internal resistance of this is the second cell, this is the internal resistance of this is the third cell, this is the internal resistance of this, and the fourth cell, it is connected in the reverse direction. This is minus, this is plus, and the internal resistance. So in resistance, whether you change the terminal, it doesn't matter, right? So this is 1.5 volt, this is 1.5 volt, this is 1.5 volt, this is 1.5 volt, and the internal resistance is giving us 1 by 4 ohm each. Right, so this is your entire combination of the battery, right? Now this is connected across a 1 ohm resistance. So this whole combination of this cell making a battery is connected to a, he's saying 1 ohm resistance. This is your 1 ohm resistance. Now he's asking find the current in the circuit. So we know that V is equals to IR. So I can write that I is nothing but V upon R. So I need to find the total voltage in this circuit and the total resistance in this circuit. Then I will be able to find the value of I. So this voltage in plus minus same polarities. You can see in the same direction these plus minus is arranged, right? So these will make these all these combinations will make what 1.5 plus 1.5 plus 1.5. So this will be what 4.5 volt. But what will happen? 1 will be minus. Now from this 4.5 volt, the potential difference supplied by the one cell will be reversed because the polarity of this is reversed. So this will, the resultant potential difference is now, you can say 3 volt. So I can draw the diagram like this. Let me draw it a battery because this is a nothing but a battery only now. So this is your now 3 volt is thus applied, and the internal resistance will be R in what? Because you can see there is a single loop, so these 1 by 4 1 by 4 1 by 4 are in series. So what is the R internal? That is the internal resistance total is 1 by 4 plus 1 by 4 plus 1 by 4 plus 1 by 4. So that makes what? It makes equal to 1 ohm. So this is what your internal resistance of the battery, and now this is connected to your 1 ohm resistor. So this is the final circuit which you are left with, right? This is the final circuit which you now have. Okay, this one. So what you will do now? You will place the value of V. So I is equals to V is what? 3. And resistance, again these 1 and 1 are in series. So this is 3 by 2, or you can say 1.5 amperes. So answer is 1.5 amperes, right? So only the important concept here was that actually in practical life each cell is having some internal resistance, and the cells are connected in a series, so the resistance are also are in connected in series. So that is the internal resistance are connected in series, and one of the polarity is reverse. So from the total series combination of the battery, this reversed terminal will get subtracted, right? So this is how you solve these type of questions. Let us move to the next one. So he's saying that the equivalent resistance between X and Y he is asking, right? So this is nothing but your problem related to the equivalent resistance combination, right? So I told you that if this kind of pattern is observed, you can always redraw the circuit, right? So I am drawing like this. Suppose this is was your X terminal, so this is X, nothing but only X only, and I am considering this as A, this as B, and this as Y, right? So now between X and A there is 10 ohm, so I will draw 10 ohm like this, and between let us mark this. This point is nothing but Y only. See there, this point is A, and a simple wire is connected with no resistance inside, right? Here there is no resistance. Directly these points are connected. That means A point is nothing but same as B point. So that is means this is like this only, right? And this point is connected to this point. That means this point is Y only. So this means that this point is Y only, this point is B. So this point A is nothing but equal to A only. So these points are nothing but same, right? So between A and Y there is 10 ohm. So there is 10. And between Y and A again there is a 10 ohm, right? So I can draw like this now. Because what happened, you see that this A is connected to this point, so this point is nothing but A only. These 2 points are nothing but same in the meaning that there is no resistance connected. So this potential at this point and potential is at this point is same, so they are that is they are not having a potential difference. That means if 2 points are not having potential difference, they can be considered as the same point only. So that is the meaning. So this is your A point, B point only, right? And this is Y point. So between A and X 10 ohm, between A and Y again 10 ohm, and between Y and A again 10 ohm. So I will connect like this, another 10 ohm, right? And between A and Y again 10 ohm, like this, right? So this is the meaning. So now I need to find the resistance between this X and Y. So again I can draw, there is a simple 10 ohm resistor, right? And this point is same, then these three resistance are in parallel. So I can draw like this. This is your X point, this is your Y point, right? I am drawing this. So these are our 10 ohms. So these are parallel combinations. So what will be this resistance is 1 by 10 plus 1 by 10 plus 1 by 10. This will be 1 by, suppose this is your R2 and this is your R1, right? So 1 by R2 is what? 1 by 10 plus 1 by, that is 3 by 10. Or you can say that R2 is nothing but 10 by 3. And these R1 and R2 are nothing but in series combination, right? So R1 plus R2 will be your answer, and it is 10 by 3 plus 10. So this will be what? 10 plus 30 by 3, which is 40 by 3. So answer is 40 by 3 ohms. B. Right. So nothing was of greater importance here other than just observing that these points are same. Right. Again, I am telling you that I consider this point as A. If I consider this point as B, these are nothing but the same points only. This is A point only, or these are same point, because a simple wire is connected, right? And here also a simple wire is connected, right? So this is, if this has a potential of Y, this is also a potential of Y, right? So you can put this point as Y also, this point as A also, right? So in finally you are having 3 points only. One is X, one is A, and one is Y, right? And then you will, what will you do? This is A, this is Y, and between X and A you can say 10 ohms. Between A and Y you can see 10 ohm. Between A and Y again 10 ohm. Between A and Y 10 ohm. So 3 10 ohm resistance between A and Y. So this is how you draw the circuit and you find the resistance like this. So right now this question, please read this question. This is seems to be a good question. A 10 ohm resistance wire AB of length 2 meter, right? So this is AB length, right? So the length of this AB is what? AB is equal to 2 meters, right? And 10 ohm resistance, right? So this RAB is what? It is equals to 10 ohms. Is connected in circuit, right? So this resistance of wire, that is 10 ohm, it is 2 meters long, and it is connected in this way. So he's asking what is the reading on the voltmeter. That means voltmeter. What will voltmeter determine? I told you that voltmeter will determine nothing but potential difference, right? So the potential difference it will determine. So now he is telling that the jockey is at point C. So what has happened? Instead of voltmeter, we can connect the voltmeter towards this AB. So if I connect this voltmeter towards to the B point, what will be happening? This voltmeter will be reading the uh, voltage across this whole 10 ohm resistance. But now what happens? You know that he's asking you if the jockey is point C, what will this voltmeter read? So I told you that resistance is equal to rho L by A. That means resistance is directly proportional to length. So you can see that there is one-to-one relation between resistance and length. So what I mean is that I need to find the value of this resistance, that is at 1.6 meter. What will be the value of resistance of this wire? Because we are reading the voltage potential difference or the voltage drop across this 1.6 meter only, right? Not the 2 meter. So we know that resistance is directly proportional to length. So by unitary method, I can directly find that 2 meter resistance, right? 2 meter resistance is having 10 ohm resistance. So what will be the resistance of 1 meter? It will be 10 by 2, which is equals to 5 ohm. So 1 meter is having a 5 ohm resistance. So what will be the resistance of 1.6 meter by unitary method? Because there is a linear relation. So I can use the unitary method. So it will be 5 into 1.6. So this will be equal to what? 8 ohms. It is 8 ohms. So what is the resistance of this 1.6 meter? 8 ohms, right? So 1.6 meter is having this 8 ohm resistance. So what is the remaining length? So the remaining length is what? It is nothing but 0.4 meter. So that means 0.4 meter is what? Total 10 ohm minus 2 ohm. It is not minus 8 ohm. It is nothing but 2 ohm. So actually what happens? You can reduce this circuit as this 12 volt battery is connected to this 8 ohm resistor, right? And this 2 ohm resistor, right? And across this, now why I am telling this? Because this was the resistance R1, R2. This is 2 ohm. So this is having the 1.6 meter length, and this is having the your rest remaining 0.4 meter length. Now the voltmeter is connected at C. That means across 1.6 meter only. That means here the voltmeter is connected. So what will be the reading of this voltmeter? That is the potential difference across this resistance. So what will be the potential difference across this resistance? Now what will be the resistance? So I can find the total current from here. So the total current is what? Total voltage upon this resistance R1 plus R2. So this is nothing but 12 by 8 plus 2 or 10 ohm, which is 1.2 amperes. That is the total current which is flowing here in this circuit. And because this is in series combination, R1 current, so IR1 is also equal to what? 1.2 ampere. And what is V? So now the value of V will be what? Value of V will be what? IR1 into R1. So this is nothing but IR1 is what? 1.2 into R1 value was what? 8. So this comes out to be 9.6 volts. Clear? So the answer will be what? 9.6 volt will be the voltage across. And if they find, suppose what will be the voltage, if they ask you what will the voltage across the remaining part, so it will be what? 9.6 voltage is the drop across this. So we know that V total is equal to V1 plus V2. So this is 12. So 12 is equals to, we have found one which is 9.6 plus V2. So I can find V2 from here, which is 12 minus 9.6, right? So it is what? 2.4, right? So this is how you can solve, right? Let us move to the next question. In a house, two 60-watt bulbs are lighted for 4 hours and 300-watt bulbs are for 5 hours every day. Calculate the energy consumed in 30 days. So actually you can say the hours are involved, watts are involved. We need to find the energy consumed. We know that the energy is what? The unit of energy is what? Unit of electrical energy is kilowatt hour. Right. So he's saying that 260 watt bulbs are lighted for 4 hours. So what will be the energy consumed by one bulb? By one bulb, 60 watt in one day. It is what? 60 into 4, which is 240 watt hour. Understand this. And similarly, the energy consumed by one bulb of 100 watt in one day is what? 100 into 5 hours, because it is running for 5 hours a day. So what is the total consumption of one day? So the total consumption of one day is what? This is, you will add the both the usages of this. So what it will be? It will be 740 watt hours for one day, right? Similarly, for 30 days, right, this same thing is happening. So for 30 days, it will be 740 into 30, which is what? Wait a minute. We are also having that there is not a one bulb only, right? So, we are having uh, this for one day we are not having 740 watts. Actually, it is what will be happening. This these are total three in number. Total two bulbs are here. So this will be into two, and totally three bulbs of 100 watts. So this will be multiplied by three. So this will be your 480 watt hour, and this will be your 1500 watt hour. Now for one day you will calculate, right? Because there are three bulbs of this and for this. So now you will calculate, right? 1980 watt hour. So in one day you can see that the consumption is 1980 watt hour, right? Or in 30 days you can simply multiply this by 30, right? So what it is? 59400 watt hours. Or you can convert this into kilowatt hour. If you want this into kilowatt hour, you will put the point here, right? So it will be 59.4 kilowatt hour. So this is your energy consumption for 30 days, right? So in 30 days, 59.4 kilowatt hours or 59.4 units will be consumed. And suppose if he asks you that the rate is suppose X rupees per kilowatt hour, then what will be the cost of the electricity bill? Then you simply multiply this by X, you will get the rupees. Okay, let us see the next question. So he's saying that an electric bulb is rated as 10 watt to 20 volt. How many of these bulbs can be connected in parallel across the two wires of 220 volt supply line if the maximum current is this? So I told you that in the first question also that the ratings when we are using, right, especially this power and voltage are of significance, right? This is the, because voltage is going to be same everywhere, right? Because whatever the device or the bulb or whatever the appliances we are using at home, they are operated in parallel, so voltage is going to be the same. So that is why once the potential difference or the voltage rating is specified and the power rating is also specified, as I told you that P is equal to V square by R, right? According to this R, this power is controlled, right? So he is giving the power rating as 10 watt to 20 volts, right? So how many of these bulbs can be connected in parallel? So he is saying that suppose a 220 volt supply line is here, right? So suppose this is your 220 volt, right? And across this 220 volt, he's saying that he's first of all mentioning that the maximum current which can be drawn, like 5 ampere, is the current which can be extracted from this from this supply line, right? That is from the source. So how many? Now you are connecting this in parallel. So these electric bulbs are identical. So suppose the resistance of one bulb I am saying is resistance of this electric bulb. I am telling it as, let us consider it as R. So that means this R is connected like this, right? This R is connected like this. Again R is connected like this. Again R is connected like this. And till, let us say, upon up to uh, n times. That is up to n number of times these R is connected. So I told you that what will be the parallel combination. So the R equivalent, you know it as 1 by R plus 1 by R plus 1 by R plus 1 by R, and it will continue. We don't know, let us say up to n times, right? Up to n times. Because we are considering that there are, let us say that n bulbs are connected, right? I am considering. Right. So you can write this as also 1 by R equivalent is this 1 by R, 1 by R, 1 by R is nothing but n times this 1 by R is coming. Now I want the value of this resistance R. You know the rating is given here, right? So we know that P is equals to V square by R, or I can find here R is equals to V square by P from this. So this will be V square is what? 220 given. So it is 220 into 220, right, upon power is 10. So this gets cancelled, and this R will come out to be 22 into 22, that means 4840 watts, ohms, right? So this is your resistance. So this R value you know. Now I need to find this R equivalent. Now let me consider this R combination as what? R equivalent only we are considering. So if I am writing the formula V is equals to I R equivalent, if I value given to is 5, V value is given to as 220, what is the value of R equivalent should be? It should be 220 by 5. So this comes out to be 44 ohms. So R equivalent should be your 44 ohms. That means I can write from here that 1 by 44 is nothing but n number of resistors, and this is nothing but R value also I calculated 1 by 4840, right? Or I can write the value of n here is 4840 by 44. So this is 44. One times it will go, and again one times it will go. That means total number of bulbs can be, how many can be connected? 110. So 110 bulbs you can connect in parallel. Then they will draw the then they will can draw the maximum current of 5 amperes, right? So you can drastically see that the resistance of this bulb, the rated resistance of this bulb is, you can see it is very high. And 100 times when we calculate 100 times with this 4840 will be connected in parallel. So this resistance reduces to only 44 ohms. So that is what I was telling, that when the number of parallel combination, the resistance keeps on increasing, what will happen? The equivalent resistance will go down, right? So this is how you solve. Let us move to the another question. Now, two exactly similar heating resistance are connected. So similarly heating resistance, right? Similar heating resistance. So similar heating resistance, this word has been used. It means value of resistance is same. Let us say R here. So two exactly similar resistance are connected in series and parallel in two different circuits, one by one. Okay. If the same current is passed through both the combinations, is more heat obtained per minute when they are connected in series or when they are connected in parallel? Give reasons. Okay. He is telling that first time these two exactly similar heating resistance are there. So I am considering that these first one is connected like this. Let us say some first we are connecting them in series. So this is having resistance R, this is having resistance R. And he's saying the same current is passed through both the combinations. That means combination meaning what? Combination meaning what? The equivalent, through this equivalent combination. So this is the equivalent combination. So to this equivalent combination, he is saying that the value to be passed is what? Same. Let us say I current is passing here. And similarly, in parallel combination, these resistance will be connected, or these coils will be connected like this. And this will be your, now what will be your combination? This is now your again combination, right? So this is your R equivalent. So again through this the same current must pass. He is saying this, that these are the two different combinations separately. First, in this first case, in the first case, these are connected in series and the current I is to be passed through the combination. And again in the second case also, this I current is to be passed in the combination. So he's saying that uh, same current is passed. In which of the connection more heat is there, right? So let me consider this first one, right? So what is heat means what? Heat means what? Your heat is what? H is nothing but I square R T, right? He is saying per minute. Per minute means, in let us say for in first case the heat is H I square R T, right? So R1T. That I am considering, then the first case the equivalent resistance is R1, in the second case the equivalent resistance is R2, which is, so H2 will be let us say uh, I square R2 into T. Now this T will be same because in per minute in both the circuits is asking, right? So this value of heat will be reduced down to I square R, and which is nothing but your power. That is the I square R, in whichever case it is more heat will be produced in that particular. Now let us consider here. So you can see this is series combination. In this circuit, the current through this is I only. So what is the heat here? I am not considering time for the moment, or you can say if I am considering the power only, that will be governing your heat generated more, because per minute in this side time we are considering same in both the case. So I can see, I can consider the power also. In whatever case the power is more, the heat will be more. So in this case the power will be what? I square. Here also, since the same I current is coming here, so here the power will be what? I square. So what is the total power here? So this I square R and this I square R. So this is nothing but 2I square R is the total power in this case. Right. Now let us come to this case. Now I current is coming to this combination, and you can see these two are having the equivalent, the same resistance. That is two roads are here. One is having this resistance R, this resistance R. That means potential, or the potential difference across both these resistance will be same. So current is now dependent on the resistance. Since the value of current is same, the value of resistance is same, the value of current will also be the same, right? That is what I am telling. So what, suppose the voltage across this is what? Suppose it was V, right? So the current, let us say this was what? I1, this is I2. So I1 was what? V by R. I2 was what? V by R. Now we know that I is nothing but I1 plus I2. So that means I1 and I2 are same, right? I1 and I2 are same. So that is why I can write it as, let us say I1 and I2 are same. So I can write I as I1 plus I1 only. So this implies that 2I1 is equals to I, or I can write that I1 is equals to I by, which will be equal to I2 also. So that means I by 2 current is here and I by 2 current is here. Right. So what will be the power in this case? The power in this case, it will be current times square R. So what is the current here? I by 2. So it is I by 2 square into R in this case. And in this one, this was your P in this case. And for this case, I am telling it will be equal to again I by 2 whole square R. So what is this? This is nothing but I square R by 4, and this is also I square R by. So if I sum of these two, what will be the sum of these two? You can clearly see that the power consumed here in this parallel combination is coming to be less. So the total power in this will be I1 I square R by 4 plus I square R by 4. So this is what? 2 I square R by 4, or you can see I square R by 4. So you can see that in this combination it was more power, and here you can see it is I square R by 2. So this is less. So in this case, less power is consumed per minute, and in this case, if you just multiply with this time, it will be energy only. So you can see that here the power consumed is more. So that is why in this combination, the energy will be more. So in series, the heat will be, because of the simpler reason that the current in both these resistance and series combination is nothing but same, and it is the I value. But in the parallel combination, the reason is that he's asking the reason also. But what happens in parallel combination? The current reduces to the half, right? Since power, you know that power is equal to I square R. So in the first case, you can see the series combination. In both the cases, I square power R was the power. But in the second combination, what happened? The current was reduced by half. So that is why the square of half become 1 by 4, and the power reduced by 1 by 4 in each resistor. So combined effect, we observed that it was the I square R by 2 times is the power in parallel combination. In series combination, we can easily see that the heat will be more, because heat is what? I square RT, that is the formula of heat, right? And I square R is power only. So I am considering power I square R, because I am using this only because in both the case you need to calculate per minute. So either you multiply this by per minute, the value in whatever case this value is going to be greater or less, that will determine in which case the heat will be more. That is in power, whatever the circuit the power consumed is more, the heat is going to be more in whatever time you say. Okay, that is the meaning. Now let us move to this question. You are supplied with few 100 ohm resistors. How would you combine minimum of these resistors to make 240 ohm 250 ohm? So your target is to make 250 ohm resistor, and you are given 100 ohm resistors. So I told you that in series combination, what happens? The resistance keeps on increasing, right? And resistance keeps on increasing. That is, in combination of series resistance, the always in series combination, I told you that in series, what I told you is that in series combination, the R equivalent resistance is what? It is always will be greater than the maximum value of the individual resistance, and in parallel combination, I told you what? R equivalent will be less than the minimum value in the of the resistance. So you can see from here, I need a 250 ohm resistor. So if I take this 100 ohm resistor, right, and if I connect another 100 ohm resistor, it will be going to be less than 100 ohm. So I want 250 ohm. So first what I do, I place a 100 ohm resistor. Now I see 250 ohm is the required. So 100 is what? Remaining is what? 150, and 100 is the less than 250. So again I will connect 100 ohm in series. So what I have got till now, I have got 200 ohm as the series combination. What I want more? I want this 50 ohm more. So I want 50 ohm resistance more, but I only can use 100 ohm resistor. So if I am connecting another 100 ohm in this series, now this becomes what? It becomes 300 ohm. But suppose I connect another 100 ohm like this. Now what happens? Now see the combination. This becomes what? 100 plus 100 plus this is what? 100 in parallel. That means always when you see that, you can generally, if in competitive exam, you can remember this, that suppose the number of resistance are equal and they are connected in parallel, right? So how many resistance are connected in parallel here? 3 resistance. And what is the, if they are equal values, so the equivalent resistance will be what? R by 3, right? So these 200 ohm resistance are connected in parallel. So half of will be the value of the equivalent resistance across. This will be 50 ohm. That is, if you solve this combination, it will be 50 ohm only. So that is how you combine that 200 ohm resistance in series and 2 in parallel. So this 100 plus 100 plus 50 will give you 250. So that is how you judge, right? Always in series, for this you need to understand that series combination will keep on increasing your equivalent resistance value, and the number of resistance, if you are connecting them in parallel, it will be lesser than your given resistance value, right? So this concept you can use, right? So let us now see the next question. So in the circuit shown below, if the potential difference between B and D is 0, okay, then the value of unknown resistance X is. So you can see that he's saying that VBD is going to be 0. So what is the combination? If this potential difference is going to be 0, then I told you that this combination should be a wheatstone bridge, right? That is, suppose I am calling this resistance branch as R1. This resistance branch is, let us say, consider R2. This, consider this branch is R3, right? And this is your R. So if VBD is equals to 0, then this type of question can be asked in your competitive examination, right? Then we know that R1 by R2 is equals to R4 by R3. So what is R1 here? R1 is nothing but 12 plus 4, right? This 12 and 4 in series, so it is 16 ohms. What is R2? R2 is nothing but 1 plus 3, right? It is nothing but 4 ohms. R3 is what? Now this 1 ohm and 1 ohm in parallel. So that means 1 by 1 plus 1 by 1, that is 1 by, so that is what? 1 by 2 ohms, right? 1 by 2 ohms, because 1 by R equivalent is what? 1 by 2, 1 by R equivalent you will get as 2 ohms, right? So it 1 by R equivalent is what? 1 by 1 plus 1, that is 1. That is 1 by R equivalent is nothing but 2, or R equivalent you can write is at 1 by 2. That is the meaning I am telling, right? So I can write this 1 and 1, as I told you that directly you can write this combination to be as half of this one. So it is 1 by 2. And R4 is what? It is your. So we will use this. Why we are using? Because the voltage difference B and D, there is no voltage difference, no potential difference. That means it is a bridge, wheatstone bridge condition. Now we put the value in this. So it is 16 by 4, and R4 is X by 1 by 2. Right. So X you can find it as 4 into 1 by 2. So this is nothing but 2 ohms. Right. EMF cell is not needed. Right. EMF cell is not needed. Sometimes this people mark this. This is not needed, because if the potential difference is 0 between these 2 points, then only the value of resistance, if we know the 3 resistance, we can find the one unknown. Right. So answer is what? 2 ohms. Right. Now let us see the next question. Cooler of 1500 watt and 200 volt and a fan of 500 watt 200 volt are to be used from a household supply. The rating of fuse to be used is, right. Now, as I told you that when we are considering the household connections, right, here there is nothing mentioned about the combination to be used between this cooler and fan. But in household, I told you that the parallel combination is to be used. So that is why I will consider that this is a parallel combination only. So what happens? Let us say the cooler will be having some resistance. Its resistance is RC. The fan resistance is, let us consider, RF. So what will be the connections first of all? This will be your cooler, and let us say this will be your fan, which are connected in parallel. Some resistance will be there, and this combination now is connected to the source, which is your, we will consider the source to be 200 volt, let us say, right? The rated voltage rating is 200 volts, so that is what we are going to apply. Now is asking that the fuse to be used. Now what will happen in this circuit? Let us say these two are the loads. To drive these two loads, we are using a single fuse, right? So fuse symbol is sometimes drawn like this, also like this is drawn, right? So this is also a fuse symbol or this. So this is a fuse. So fuse protects your devices from overcurrent. So let us say this is using some getting some or drawing I1 current. This is I2 current, and this current will be what? It will be I current, total current. So this I current must be I1 plus I2. This is the rated current of this fan, or let us say that as IF, and this is the rated current of this cooler, which is IC. So but IC and IF summation is the total rated current. So this, if the current drawn by these resistance is more than this I, then this fuse must melt, right? So the rating of fuse, that is the current rating of this fuse, we need to be equal to this value of I. So to calculate this I, we are having this 200 volt, but we don't know the resistances of this, right? So from the given data, we can easily find the value of cooler, right? So resistance of cooler is what? We know that power is equal to V square by R, or I can write R is equal to V square by P. So similarly, I can write from here that RC is what? Voltage square, that is 200 into 200 by 1500, and this is nothing but your 400 by 15, right? So this is nothing but 80 by 3 ohms. Similarly, for fan, I can write as 200 into 200, and the wattage is what? 500. So this is what? 400 by 5, or I can write 80 ohms. So this value is equal to now 80 by 3 ohms, and this is now 80 ohms. So these are in parallel, right? So I need to find the parallel combination of these two. So R equivalent I will find, right? So what is R equivalent? It is nothing but 1 by R. 1 by R equivalent is what? 1 by RC plus 1 by RF. This is 3 by 80 plus 1 by 80, which is 4 by. So I will reciprocate this to find R equivalent. It will be 80 by 4. So this is 20 ohms, right? So now I am having the value of this equivalent resistance. So what is the voltage value? V is equals to I R equivalent, right? And we need to find this I. So it is what? Total voltage, which we'll be saying that it is rated only 200 volts, and equivalent we find 20 ohms. So this comes out to be 10 ampere. That means the rating of this fuse must be 10 amperes, right? D is the answer. 10 ampere. So when more than 10 ampere we will be using, when more than 10 ampere, suppose some fault occurs and some of the there is some mishappening here in this connection, then if the current drawn is more than 10 ampere, this will, what will happen to this? This will melt, and it will melt. This wire will melt, fuse wire will melt, and the connection will be open. Then the cooler and fan will be protected from overcurrents. That is more than 10 ampere. If this total circuit is drawing, it will be, these devices will be now safe, as the fuse will melt if current is more than 10. So you will be using 10 ampere. So if the what will happen, let us say if you are using the rating less than 10 ampere, right? Fuse rating of fuse is, suppose you are using less than 10 ampere, what will happen? Before even every time, what will happen? This fuse will get melt, because before this 10 ampere, this fuse will, as you switch on the circuit, quickly the fuse will, right? And suppose if you are using the fuse current which is more than this 10 ampere, suppose the rating of fuse current, if you are using more than 10 ampere, what will happen? Still, if there is more than, suppose 12 ampere current is flowing, right? And the rating of this is suppose 15 ampere. So if more than desired current is flowing, then what will happen? There will be overheating in this cooler and fan, overheating. And due to this overheating, this will get burned, because this will never melt, because you use more than the rated value of fuse. That is why your device will get damaged. So that is how ratings are decided, and a proper uh, ratings of fuse are used different in different cases. Okay, that is the case. Sometimes, since let us say our extensions which are specifically used in our computers and all, we are having extension, there is a switch there, and in line there are so many sockets like this, right? This is generally a cord of a let us say computer extension like that, there is a small uh, cylindrical fuse there, right? Cylindrical fuse is there, right? Cylindrical fuse is there, and it is having a wire here, and these are having some cylindrical fuse is there. When you open this, there is a fuse, and this is having a different rating, right? And some fuse which were in older times in your main near the meter boxes in your homes, they were fuse were like a socket, like a socket made of porcelain. Their cover was made of porcelain, or you can say when you remove that in a plug kind of form, you will find a wire inside of that. That is nothing but your fuse wire. So the meaning is that fuse are available in different rating. Like this is having a very thin wire because the rated current value is not very large. But when you talk about the your main meter boxes, the current values are very high there. So the fuse is also large. The wire is also thick there because large current rating is there. Right? Cylindrical fuse is used. This kind of fuse, as I told you that, but still today we are not using fuse. We are using in that place of fuse we are using MCBs, right? So these were some of the questions, right? The difficulties of the question was ranging from, some of the questions were from from your competitive examination, so they can be beneficial here. The routine questions everybody can solve, right? So that is the, you can practice questions like that more. Okay, so that was all for this class. Let's meet in the next.